we will discuss about Newland law of octaves. Okay, John Newland was the British chemist. Okay, now we will discuss about Newland's law of octaves. So what he said, he is also explained about the classification of elements. This John Newland was a British chemist. Newland in 1965 he found that when elements were arranged in the ascending order of their atomic weight, they appear to fall into 7 groups. Okay, this Newland in the year 1865 he found that when the elements were arranged in the ascending order of their atomic weight, they appears to fall into 7 groups. Okay, each group contained the element with similar chemical properties. Okay, so he arranged the elements in the increasing order of their atomic weight, then it appears to be that fall into 7 groups. Okay, and each group contain with in each group contain the elements with similar chemical properties. I mean, each group that elements will be there that have similar chemical properties. Based on this observation, Newlands proposed the law of octaves. Okay, so based on these observations, Newland he proposed the law of octaves. What is that law of octaves? Now we will discuss. The law of octaves states that when the elements were arranged in the ascending order of their atomic weight, they fall into a pattern in which their properties are repeated at regular intervals. Okay, so this law of octaves states that when the elements are arranged in the ascending order of their atomic weight, means here the elements are arranged in the ascending order of their atomic weight, they fall into a pattern with which their properties repeated regular intervals. Okay, I will explain by this table. Every ith element starting from a given element resembles into its properties so that of the starting element. Okay, so he arranged the elements in the increasing order of their atomic weight, then that falls into 7 groups. In that, first element and ith element property is similar. Okay, first element and ith element property is similar. Okay, so once you observe this table, so this Newland's table of elements. So element with similar chemical properties are to be present along the horizontal row. Okay, the elements which have similar chemical properties are that presented along the horizontal row here. Newland was the first to assign atomic number to elements, means he only assigned the atomic numbers to elements first time, means he only given the atomic number to elements. Unfortunately, his work was neither accepted by his seniors nor by the juniors of the Chemical Society, with rejected its publications. Here the elements with similar chemical properties are to be present along a horizontal row. Newland was the first to assign the atomic numbers to elements, means he only given atomic numbers to element first. Okay, he assigned the atomic number to the elements first time. Okay, is only unfortunately his work was neither accepted by his seniors nor by the juniors of the Chemical Society, which rejected his publications. In Newland's table of elements, if we start with hydrogen and move down and then start at the top of the ith element is fluorine, and the next ith element is chlorine, and so on. The properties of hydrogen, fluorine and chlorine are similar. Okay, once you observe the Newland table, in this first element is hydrogen. Okay, so first hydrogen, after that lithium 2. Okay, next to 3, 4, 5, 6, 7. Upside what is there? Fluorine is ith element. Yes or no? Okay, ith element is fluorine. If you start with hydrogen and move down, then start at the top of the ith element is fluorine. Okay, when we start from hydrogen, when we move down, after that ith element is which one? Fluorine. Okay, next, and the next ith element is which one? Chlorine. Okay, okay, here hydrogen is first element. When we move down, the eighth element is which one? Fluorine. Okay, after this fluorine, once you move down like this continuously and count, okay, 1 2 3 4 5 6 7 8th after the fluorine. From fluorine once again you count from 1. Okay, 1 2 3 4 5 6 7 8. Eighth element is which one? Chlorine. Yes or no? Okay, so means if we start from hydrogen, when we move down, the eighth element is fluorine. Now once again count from fluorine. Okay, fluorine 1, sodium 2, magnesium 3, aluminum 4, silicon 5, phosphorus 6, sulfur 7, chlorine 8, like this imagine. Okay, and from fluorine and chlorine, in this fluorine is first element, chlorine is eighth element. Yes or no? These properties of this hydrogen, fluorine and chlorine are similar. Okay, like that he said. Okay, so Newland table of elements, if you start with hydrogen and move down, and then start at the top of the eighth element is fluorine, and the next eighth element is fluorine, and so on. These properties of hydrogen, fluorine and chlorine is similar. Okay, similarly if you start at lithium, okay, here second element lithium is there, no? Start from lithium, then the eighth element is which one? Start from the lithium 1, next to this lithium 1. Okay, lithium to start, lithium 1 2 3 4 5 6 7 8. After the lithium eighth element which will come? Sodium will come. Okay, and next coming eighth element which one? Sodium 1, magnesium 2, aluminum 3, silicon 4, phosphorus 5, sulfur 6, chlorine 7, potassium 8. Okay, like that 8 will come in the second row. This lithium is first element and sodium is eighth element will come. If we take sodium as a first element, next eighth element which will come? Potassium will come, like this. Okay, this element shows the similar and physical chemical properties. Okay, so this law of octave states that when the elements are arranged in the ascending order of their atomic weight, they fall into a pattern in which their properties are repeated in regular intervals. Means every eighth element starting from a given element is resemble in its properties to that of a starting element. Means here according to this Newland, if you arrange the elements in the order of the ascending order of their atomic weight, then that falls into groups. Okay, that falls into 7 groups. So here first element and eighth element property is similar. For example, here hydrogen is first element. After that eighth element is which one? Fluorine. That property is similar. If the fluorine is first element, after that eighth element is which one? Chlorine. That properties are similar. Means in each group the elements which are coming that are having similar properties, like that. Okay. Next, if you start from lithium, eighth element is which will come? Sodium will come. Okay, and sodium imagine has a first element. After that eighth element which will come? Potassium will come. Okay, means move down and count the number 1 2 3 4 5 6 7, like that. Eighth element which will come? Potassium will come. So these have similar properties. Lithium, sodium, potassium, like that, these are having similar properties, he said. Okay, unfortunately his work was neither accepted by his seniors nor by the Journal of the Chemical Society, with rejected its publications. So in this Newland table also some limitations are there. Okay, what are that? See here. Okay, in this also some limitations are there. What are that? Now we will discuss. In this Newland table also some problems are there. What are that? See here. There are instances of two elements fitted into the same slat. Example, cobalt, nickel. Okay, so here this Newland, he filled the two elements in the same slat. Okay, so in some situations in this Newland table we can observe two elements in one slat. Okay, example, cobalt and nickel. Okay, so cobalt and nickel once you observe. Okay, so he filled in the same slat. Okay, next, certain elements totally dissimilar in their properties were fitted into the same group. Okay, so certain elements that have totally dissimilar in their properties but that were fitted into the same groups. What are that? Now we will discuss. For example, he arranged cobalt, nickel, platinum, palladium and iridium which have different properties compared with the halogen in the same row, fluorine, chlorine, bromine, iodine. Okay, in the the Newland first horizontal row. Okay, so here certain elements totally dissimilar in their properties were fitted into the same group. Some elements are there that having dissimilar properties, but he fitted that in the same group. What are that? See here. Once you see the Newland first horizontal row, Newland's first horizontal row, once you see, okay, so here cobalt, nickel, platinum, palladium and iridium. There are another cobalt, nickel, platinum, palladium and iridium. So which have different properties. These have different properties when we compare with halogens in the same row, fluorine, chlorine, bromine. Okay, so here cobalt, nickel, platinum, palladium, iridium, that having different properties when we compare with the fluorine, chlorine, bromine, iodine. Okay, why? Because this fluorine, chlorine, bromine, iodine are halogens. This cobalt, nickel, platinum, palladium, iridium are having different properties when we compare with fluorine, chlorine, bromine, iodine. This is one of the mistake of Newland. Okay, this is one of the mistake of the Newland. Okay, and he fitted two elements in one slat. That also one of the mistake of the Newland. Next, he was found that the law of octaves holds good only for the elements up to a calcium. Okay, so this law of octaves means he said the first element and the ith element properties are similar, means when he arranged the elements in the increasing order of their atomic weight, then what happened? It falls in 7 groups. In that the first element and the 8th element property is similar, he said. Okay, yes or no? And we observe that in hydrogen, fluorine, chlorine, lithium, sodium, potassium. Yes or no? So like that he said. But he was found that the law of octaves holds good only for the elements up to calcium. Means this is suitable up to calcium only. Okay, and this law was not valid for the elements that had atomic masses higher than the calcium. So the elements which have the atomic more than the calcium, for that this law is not valid. It was found that the law of octaves holds good only for the elements up to calcium. Means first element, the ith element property similar, he said no, this is valid up to calcium only. Okay, and this law was not valid for the elements that had atomic masses that had the atomic masses higher than the calcium. Means the elements which have the atomic mass having, okay, the elements which have more after the calcium, this law is not valid. Since this law is not valid for the elements that had atomic masses higher than the calcium. And the Newland periodic table was restricted to only 56 elements. Newland periodic table was restricted to only 56 elements, and he did not leave any room for the new elements. Okay, he did not leave any empty room for the new elements, and his periodic table was restricted to only 56 elements, and elements that were discovered later could not be fitted into the Newland table in the accordance with their properties. Means here this Newland periodic table were restricted up to 56 elements only, and he did not leave any room for the elements which will discover in the future. Okay, next, Newland attempted to link the periodicity for the chemical properties of elements with the periodicity found in the music. In a musical scale, any note in a key is separated from its octave by interval of 7 notes. This must have made him to force all the elements into his active pattern, sometimes without caring the similarities. Okay, Newland attempted to link the periodicity of the chemical properties of elements with the periodicity found in the music. In musical scale, any note in a key is separated from its octave by the interval of 7 notes. So this must have made him to force all the elements into this active pattern, sometimes without caring the similarities. Okay, so in musical note like this, sa, re, ga, ma, pa, da, ni, sa. Like that will be there or not there? Okay. So here a musical note like this: sa, re, ga, ma, pa, da, ni, sa. Like this is there. In this, which is first one? Sa. After that, eighth one, which one? Sa. Yes or no? Once you right hand count. Yes, okay. In this first note and eighth note, same or not there? So, like this, in Newland periodic table also, first element and eighth element properties are similar. Yes or no? Yes. Here we compare now. First element is hydrogen. If we move down like that downside, when we go to eighth element is fluorine. This first element and eighth element property is similar. Like this, if you start from fluorine, if you move down, which is the eighth element? Chlorine. So fluorine, chlorine, these two properties similar or not? Similar. Means like this. Means sa, re, ga, ma, pa, da, ni, sa. So in that first one what? Sa. Eighth one what? Sa. Like this here also. First element is hydrogen and eighth element is fluorine. These two properties similar or not? Similar. Like this. Like that if we start from lithium, lithium is first, imagine, and the eighth element is which will come? Sodium will come. This lithium and sodium properties are similar. Okay, and if you start from sodium, which will come and move down, which will come eighth element? Potassium. Sodium and potassium properties are similar. So means Newland compared this his table with the musical note sa, re, ga, ma, pa, da, ni, sa. Means in that also first element, first letter and eighth letter, that first note and eighth note same coming or not? Like this here also first element and eighth element properties are similar. Like this he compare. So this John Newland was the British chemist. Newland in 1865 he found that elements were arranged in the ascending order of their atomic weight. They appears to fall into 7 groups. In that each group contained the elements with similar chemical properties. Based on these observations, Newland proposed the law of octaves. This law of octaves states that when an elements were arranged in the ascending order of their atomic weight, they fall into pattern in which the properties are repeated at regular intervals. Every eighth element starting from a given elements resemble to in properties that of the starting elements. He arranged the elements in the increasing order of their atomic weight, then that falls into 7 groups. In that every first element and eighth elements properties are similar, like hydrogen, fluorine, chlorine, and lithium, sodium, potassium, like that. Okay, and what are the limitations? There are instance of 2 elements fitted in the same slot. So in this Newland law of octaves also some mistakes are there. What are that? Means he fitted the 2 elements in same slot. Example, cobalt, nickel. And certain elements totally dissimilar in properties he fitted in the same group, like cobalt, nickel, palladium, platinum, iridium will be there, no, that having different properties when we compare with the halogens, fluorine, chlorine, bromine. So but he arranged this all in same group. Okay, so that is one of the mistake. And his law is valid up to calcium only. After this calcium, this law is not suitable. Okay, and Newland table was restricted to only 56 elements. So Newland periodic table was restricted to only 56 elements, and he did not leave any room for the new elements. Okay, so means in that Newland periodic table only 56 elements only there. In future in some more elements will be discovered or not, but he did not leave any empty place for the elements which will discover in the future. Okay, and Newland attempted to link the periodicity of the chemical properties of elements with the periodicity found in the music. In musical scale, any note in a key is repeated from its octaves by the interval of 7 notes. This must have made him to force all the elements into this active pattern, sometimes without carrying the similar properties. So means Newland compared his classification with the help of musical note. In that musical note also first note and second note it's same or not? Sa, re, ga, ma, pa, da, ni, sa, sa, and last sa, re, ga, ma, pa, da, ni, sa, and first and eighth note same coming or not? Like this also when he arranged the elements in the ascending order of their atomic weight, in that also first element and eighth element properties are similar, like that he said. Okay, so after this, in this Newland also some mistakes will be there now. So after that, Mendeleev, one more scientist came. By depending on the Dauvergne and Newland, he classified the elements in different way. How we classify the elements in different way, we will discuss in next.